Welcome to qnawire.
Okay, so we need to determine the diameter of the object lens telescope. So, what we know now is the outermost ring of the mountains has a diameter of 1300 kilometers. Okay, and the distance, the average distance from center to center from the Earth to the Moon is 384,403 kilometers. Okay, and which is about 30 times of the diameter of the Earth. Okay, so well, we need to find d, which is the diameter of the object lens on telescope. So we don't know d, but we know such formula, which is resolution for the resolution limit, which is 1.22 lambda divided by d. So once we know the resolution limit and the lambda here, we can figure out d. So actually, we can make some assumption about wavelength, which is the lambda here. Let's say lambda is equal to 550 nanometer. This is the wavelength from the middle of the spectrum. So it's pretty average from all spectrum. And well, we don't know theta resolution here, which is a resolution limit. But there's another equation we can use to figure out resolution limit. Simply that this is another formula for the resolution limit, which is d over L. And d here is the distance from the outermost ring, and it's given is the diameter of the 1300 kilometer here. And L is the in this case the distance from the Earth's surface to the Moon's surface. But we know so far what we know. Let's go to the second page. We know that the average center to center distance from Earth to Moon is, let's say capital L here, is 384,403 kilometer. Okay, and which is 30 times, which is about 30 times of diameter of the Earth. Okay, so if we divide by 30, so that let's say the diameter of the Earth is d1, which is equal to L divided by 30, which is equal to 384,403. 403 kilometer divided by 30, which will give us, let me see, 12, 8, 13.4 kilometer, and that's the diameter of the Earth. Okay, and the diameter of the Moon is given, which is 3,474 kilometer. And let's go to the next page. Let's draw a diagram to show what is the distance between the surface of Earth to the surface of the Moon. Okay, if we draw a circle here, let's say this is the Moon. Okay, and this huge circle here is the Earth. Okay, we call it Earth. So that's the distance from the center to center. We already know is 384,403 kilometers. Okay, it's the distance from center to center. And here, this is the surface. Let's say S is the surface. This is the surface of these two planets. So we know the diameter, so we can figure out the radius, and we know the radius from the Moon. Let's say our Moon is just simply equal to the diameter, which is 3,474 kilometer. divided by 2, and that will give us 1737 kilometer. Okay, and the radius of the Earth is equal to, we know the diameter from the previous calculation is 12,813.4 kilometer. And if we divide by 2, we get 6,406.72 kilometer. Okay, so you see the distance between the surface of the moon and Earth is just simply the distance between the center to center minus the radius from the moon and minus the radius from the Earth. See right here? So let me use the red color here to illustrate the distance we need to measure, which is this part. That's the part we need to figure out. Okay, so that's the distance from the surface of the moon to the surface of the Earth. So we can simply do some algebra here, which is like this. Let's say the distance from the surface to the moon to the surface of the Earth is Ls, which is L1 minus R moon minus R Earth. And then we got 384 and 403 kilometer minus 1737 kilometer minus 6,406.72 kilometer, and we got such value, which is about 376,259 kilometer, and that's the distance from the surface of the moon to the Earth. Okay, now we can use the formula we placed on the page 1, which is data resolution limit equal to D over L, and L in this case is the surface, the distance from the moon surface to the Earth surface. So now we got the resolution limit is equal to 1,300 kilometer divided by 376,259 kilometer, and that will give us, let's take a look. Okay. It will give us 0.003455 for the resolution limit. So now we know the resolution limit, and you know we're trying to figure out D, and the relationship between the resolution limit is like this. Between D is like this: is 1.22 lambda over D, and we know D can be equal to 1.22 lambda divided by resolution limit, and that will give us 1.22 times 550. Since we make an assumption about the wavelength is about 550 nanometer, and 1 nanometer is 10 to the negative 9 meter, so 10 to the negative 9 meter. And we got the resolution limit here, which is 0.003455. And that will give us, let me see. That will give us 0.00194 meter, which is, so the final answer D, that's converted to millimeter, which is, let me see, you start from here is 0.0014 meter. So 1, 2, 3, we got 0.194 millimeter what the diameter of object lens on a telescope? And that's the answer for this question. Thank you.